Hello, my name is Selena Wu, and this is my presentation for the Charged Tapes Lab. Experiment Introduction. The purpose for this experiment is to determine how much excess charge is on a piece of tape. To find this, I charged one piece of U-shaped tape by removing it from a U-shaped base tape on the table. When I put my hand up to the tape floated closer toward my hand. However, when I placed two U-tapes side by side, they repelled each other. We know that the U-tape is positively charged since it is attracted to neutral objects such as books or my hand, and also to negatively charged objects like a pen rubbed on cloth. The U-tape must have a deficiency of electrons then, since it is attracted to the pen that had an excess of electrons. The U-tape is repelled by objects of the same charge, such as another piece of U-tape of the same net charge. These observations allow us to establish an experiment where one tape is suspended in the air by the ends and another tape is brought under it, pushing it upward. At the instance when the top tape appears to float upward, it is being repelled by the electric field of the bottom tape. And the distance between the two tapes determined that the charge of each piece of tape was 9.52 nanocoulombs. Experimental values. It was found that the tape had a length of 0.2 meters, a weight of 0.0002 kilograms, and that the distance between the two tapes when the top tape began to float was 0.0204 meters. The magnitude of the gravitational force on the floating tape was 1.96 times 10 to the negative 3 newtons. The magnitude of the electric force from the bottom tape onto the floating tape was also 1.96 times 10 to the negative 3 newtons. Assumptions and physical principles used. Firstly, we assume that the U-tapes act as point charges. Since all the charged particles in one tape are constantly interacting with all the charged particles of the other tape, the assumption allows us to calculate the electric charge of each tape by assuming uniformity throughout the tapes. We may also assume that the top U-tape and bottom U-tape have the same charge. It is reasonable to make this assumption since both pieces of tape are of equal lengths and they are charged in the same manner, both by being pulled off the same base tape. Additionally, we assume that the U-tapes are subjected to only the force of the electric field of the other U-tape and to gravity. We ignore the presence of other electric fields due to the tape surroundings. To solve for the charge of the tape, we apply Coulomb's law and Newton's second law. Coulomb's law provides the equation for calculating the force of an electric field. This is a crucial component to balancing out the force of gravity on the top tape. Newton's second law explains why the forces should be balanced and sets up the relationship that allows us to solve for the charge of each U-tape. The momentum of the top tape is not changing, and the tape is not accelerating. Therefore, as stated by Newton's second law, the momentum principle applies, and we know that the net force acting on the tape is zero. Thus, we find that the force of gravity and the force of the electric field of the bottom tape balance out, making the net force equal to zero. Finding U-tape charge. From there, we may use the formula for the magnitude of the gravitational force on the top tape and the formula for the magnitude of the electric field of the bottom tape on the top tape, set the negative of the gravitational force equal to that of the electric field force. This math supports the ideas previously stated, since the net force is being balanced to zero. Finally, we can rewrite the equation to solve for Q, with the distance found in the experiment 0.0204 meters represented as the magnitude of the vector r. Finally, we reach the result that the charge of each U-tape is 9.52 nanocoulombs, or each U-tape contains a deficiency of 5.95 times 10 to the 10th electrons. GlowScript code. Furthermore, these results can be obtained through running the calculations on GlowScript to verify the math and provide a visual representation of the force of gravity and the forces of the electric fields on each point charge. The code shown on the screen displays the calculations for the force of gravity, the charge of each U-tape, and the force of the electric field of the top tape and the bottom tape. The charge of each U-tape as calculated by the computational model is 9.52 nanocoulombs. These calculations are displayed when the program is run, and it demonstrates a visual representation of the forces acting upon the two tape point charges that led to the results of this experiment. Reflection. If electrons had positive charges and protons had negative charges, we would still observe that the two tapes repel each other and that the top tape would appear to float in the experiment since both U-tapes would still have the same net charge as one another. Similarly, the charged U-tapes would still be attracted toward my hand and toward a charged pen. This time, though, the charge of the pen would become positive while the U-tape would now have a negative charge, indicating that they would still attract each other. An important note to make for this experiment is that the U-tapes should not be handled much after getting charged, since they do give off charge to other charged or neutral objects in their surroundings. So I had to make sure to move efficiently and to not handle the U-tapes as much as possible. This step was crucial to executing the lab, and in doing so helped me to come to a conclusion with my results, stating that the charge of each piece of U-tape is 9.52 nanocoulombs. Thank you.